In this topic of the circle for the center and the radius, we will define the different things one by one, and then we will find out the radius and the center of all these figures. There are centroid, second phase is orthocenter or circumcenter, third is inscribed circle center, fourth is ascribed center circle, and the fifth is the center through the medians. So these are the five different ways, and we will calculate one by one for this. For this centroid, we know that, let's say we consider a triangle ABC. With A has the coordinate as x1 and y1, B has the coordinate as x2 and y2, and C has the coordinate as x3 and y3. And you are finding the center of this centroid figure for this triangle ABC. So what we do, we take the average of all these 3 points. So let's G is the centroid there, which is represented by xy. Then this G having the x as x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 over 3. So these are the coordinates for the centroid of this figure there. The second is orthocenter. Orthocenter means what? When circle is find it out with the help of this bisection of these sides there. Let's say ABC is a triangle given to you. You first draw the perpendicular bisector of this AB line. So AB are the two endpoints. So you draw this perpendicular, and that is a line through this part, which is going to make an angle of 90 degree, and it is dividing it into two equal parts. Then you can find out the bisector of this AC line by taking the midpoint of this, and you can find out this AC line there. And let's say this is the point which is known as to be called the center of this triangle there. And we can verify it that if we open the compass from this O to A or O to B or O to C, it will be having the same length, and that is known as to be called the radius of this circle. So you draw this compass open and find it out that it will be a circle passing from A, B, C like this. So that is why it is known as to be called orthocenter or circumcenter there. And this is the radius of the circle O to B or O to A or O to C there. The third figure we have drawn it there, that it is inscribed circle there. So you draw a triangle ABC and because you are finding the inscribed circle of this, so you are going to bisect the angles of A, B, and C. So if B angle is there, you draw the compass, open it, and draw the arc like this. Then from this point, draw an arc, and from this point, draw an arc. So this is a line drawn from this point there. Same, you can process it with the C point, and you can draw from this point and from this point, and you can get a line through this. Let's say this is O is the center. Then draw perpendicular from O to the line BC. And this is a line drawn through this. So this is the point, let's say it is D there. So O to D is the center of this, O is the center and O to D is the radius of this circle. And when you will open the compass and draw a circle from this point O, then it is going to touch the three sides. And these AB, BC, and AC will become the tangent to that circle. So this center is known as to be called inscribed center there. Then the fourth process, if there is a circle ABC, and then you are going to draw the Escribed circle for this portion. So for this Escribed circle, we do what? We extend this line and we extend this line. Then this angle will be bisected, the external angle of this. So it is from this point draw an arc, from this point draw an arc, and this is a line through this portion. Then from this C point, draw this bisector. From this point, draw an arc. From this point, draw an arc. And you can get a line through this portion there. So this is known as to be called the center of that circle. And you can open the compass and draw from this point O that it is cutting this point at three positions with BC as an external, and on this line and this line there's internal there. So this is known as to be called the center of that circle O of for this Escribed circle there. Last, the fifth, the centroid of this any triangle through median. Let's say ABC is a median to this triangle. Then median means this the opposite side to this vertex A, let's say that is BC, it is going to be bisected, and a line drawn through this point will be, let's say A to D is the median of this portion. It is not necessary to be 90-degree here. It can be 90-degree only when this AB and AC are equal sides. This is isosceles triangle, then it will be median, making an angle of 90-degree. Otherwise, it is not necessary to make an angle of 90 degrees to this part. Now, this AC has the opposite vertex B there, joining the midpoint of AC. Let's say that is the point E there. We get a line through this, and this side is equal to this side. Then ABE is also a median through this. Then AC joining the midpoint to this opposite vertex C there. This line is passing from this, and it is DEF. So this side is equal to this side. Then this is known as to be called the center of this triangle ABC through this median.